Tonight I want to take you somewhere special, somewhere that exists all around us, yet remains invisible to our eyes, a place where the most fundamental rules of reality reveal themselves in ways that might surprise you. We're going to explore one of the universe's most elegant mysteries, a question that has puzzled humanity for centuries and continues to whisper its secrets even now as you settle in for this journey. Light, that most familiar of phenomena, carries within it a paradox so beautiful, so counterintuitive, that when you truly understand it, you'll never look at a sunrise, a candle flame, or even the gentle glow of your screen the same way again. Before we drift deeper into this cosmic puzzle, I'm curious about where you are right now, in this very moment. Are you tucked into bed in a city where the lights never quite go out? Perhaps you're in a quiet countryside where the stars shine unimpeded above you. What time is it where you are? Is it that perfect hour when the world seems to pause, when thoughts turn inward and the universe feels both vast and intimate? Wherever you are, whenever you've found this moment, I'm glad you're here. If these gentle explorations of the cosmos help you find peace at the end of your day, consider joining our community of dreamers and wanderers. A simple like or subscription means we can continue these quiet journeys together, night after night, question after question, always seeking that perfect balance between understanding and mystery. You see, the question we're exploring tonight might sound strange at first, something you could easily dismiss as just another quirk of physics, but the more we look at it, the more quietly intriguing it becomes. How can light, which has no mass whatsoever, still carry momentum? How can something that weighs nothing push against objects, transfer energy, propel spacecraft through the void? It's a question that seems to violate everything we intuitively understand about the physical world. After all, in our everyday experience, momentum is always tied to mass. A rolling ball has momentum because it has weight and velocity. A flying bird has momentum because its body has substance moving through space. But light? Light has no substance at all, no weight that could register on even the most sensitive scale, and yet it pushes, it moves, it carries force across the universe. What if this apparent paradox was not just a dry equation in a textbook, but a quiet doorway into how the universe really works at its most fundamental level? What if understanding why light has no mass, but still has momentum, could reveal something profound about the nature of reality itself, about the delicate dance between energy and matter, between what we can touch and what we can only observe? Tonight, we're going to unravel this mystery together, slowly, gently, like watching the sky lighten before dawn. We'll explore how light emerges from the quantum foam of reality, how it races across the cosmos at the ultimate speed limit of existence, and how its massless momentum shapes everything from the orbits of dust particles around distant stars to the very structure of atoms in your body. We'll discover how Einstein's insights revolutionized our understanding of this phenomenon, how quantum mechanics adds layers of beautiful complexity, and how scientists today continue to probe this mystery, with experiments so delicate they can detect the pressure of a single photon. As we begin this journey, imagine yourself floating in the vastness of space, surrounded by an ocean of light you cannot see. From every direction, photons stream past you, through you, some having traveled for billions of years just to arrive at this moment. These massless messengers carry with them the stories of stars being born and dying, of galaxies spinning in their ancient dance, of quantum fluctuations in the hearts of atoms. Each photon, weighing nothing at all, nevertheless carries momentum, a push, a gentle insistence that it exists and matters in the grand choreography of the cosmos. The universe is filled with light we cannot see. Right now, as you listen to these words, radio waves pass through your body, carrying signals from satellites, from distant pulsars, from the cosmic microwave background that has been traveling since the universe was young. Infrared radiation warms your skin, ultraviolet light bounces off the atmosphere above you, X-rays from distant cosmic catastrophes slip through the Earth as if it weren't even there. All of this light, this electromagnetic radiation, has no mass. If you could somehow gather all the photons in a room and place them on a scale, the needle wouldn't move at all, and yet each of these photons carries momentum, each one capable of pushing, of transferring energy, of making its presence known in the physical world. This seems impossible, doesn't it? Our everyday experience tells us that momentum equals mass times velocity. It's one of the first equations we learn in physics class, a relationship so fundamental that it seems unbreakable. When you throw a ball, its momentum depends on how heavy it is and how fast it's moving. When a car crashes into a wall, the force of impact comes from the car's mass combined with its speed. This relationship feels absolute, carved into the bedrock of reality. So how can light, with no mass at all, still carry momentum? The answer lies in a realm where our everyday intuitions break down, where the universe reveals rules more fundamental than the ones we observe in our daily lives. You see, momentum isn't really about mass and velocity, not at the deepest level. That familiar equation, momentum equals mass times velocity, is actually just a special case, a simplified version that works well for objects moving much slower than light. The true relationship is more subtle, more beautiful, and it emerges from the very fabric of spacetime itself. Einstein showed us that energy and mass are not separate things, but different faces of the same cosmic coin. His famous equation, E equals mc squared, tells only part of the story. The fuller truth is that energy, momentum, and mass are all interrelated in a more complex dance. For objects with mass, most of their energy comes from their mass itself, that locked-up energy that Einstein revealed. But for light, all of its energy comes from its motion, from its frequency, from the oscillation of electric and magnetic fields racing through space at the ultimate cosmic speed limit. Think of it this way, and let this image settle gently in your mind. Imagine the universe as a vast ocean, perfectly still and silent. Now imagine a wave moving across this ocean. The wave itself has no substance beyond the water it moves through. It's not a thing, but a pattern, a disturbance, a traveling arrangement of something else. Yet this wave can push a boat. It can carry energy from one shore to another. It can make its presence known despite being nothing more than a moving pattern. Light is similar, but even more ethereal. It's a wave in the electromagnetic field that permeates all of space, a ripple in something that exists everywhere but cannot be touched or held. But here's where it gets even more interesting, more mysteriously beautiful. Light isn't just a wave, it's also a particle, a photon, a discrete packet of energy that behaves like a tiny bullet of pure momentum. This dual nature, this quantum identity crisis, means that light exists in a realm between our classical concepts of waves and particles. Each photon carries a specific amount of energy, determined by its frequency, its color, if you will, though most light exists in frequencies our eyes cannot perceive. And through another one of Einstein's insights, we know that energy and momentum are intimately connected. For light, the relationship is elegantly simple. Momentum equals energy divided by the speed of light. This means that every photon, no matter how faint, carries momentum proportional to its energy. A high-energy gamma-ray photon carries more momentum than a low-energy radio wave photon, but both carry momentum despite having no mass at all. It's as if the universe has two different rules for momentum, one for things with mass and another for things that travel at the speed of light. And these aren't really two different rules, but two aspects of a single, deeper truth about the nature of reality. Let's drift deeper into this mystery by considering what actually happens when light interacts with matter. When sunlight falls on your face, you feel warmth, but there's also an incredibly gentle pressure, a push so faint you'd never notice it. Each photon that strikes your skin transfers its momentum to you, giving you the tiniest of pushes before it's absorbed or reflected. The pressure is minuscule, about 100,000 times weaker than the weight of a paperclip spread over your entire body. But it's real, it's measurable, and it has profound consequences throughout the universe. In the 1960s, scientists first measured this radiation pressure directly, using delicate instruments that could detect the force of light itself. They shone lasers at tiny mirrors suspended by almost invisible fibers and watched as the light pushed the mirrors ever so slightly, proving that massless photons do indeed carry momentum. Today, we use this principle in laboratories around the world. Optical tweezers use focused laser beams to grab and move individual cells, even individual molecules, manipulating them with nothing but light. The momentum of photons, despite their lack of mass, is strong enough to push matter around at the microscopic scale. But the influence of light's momentum extends far beyond laboratories. In space, where there's no air resistance to complicate things, radiation pressure becomes a significant force. Spacecraft designers now account for the pressure of sunlight when calculating trajectories. Some spacecraft even use solar sails, vast sheets of reflective material that catch sunlight like wind in a sail, using the momentum of photons to slowly but steadily accelerate through the void. It's a form of propulsion that requires no fuel, no engine, just the gentle, persistent push of light itself. Consider the tails of comets, those spectacular streams of gas and dust that always point away from the sun regardless of which direction the comet is moving. One of those tails, the dust tail, is shaped primarily by radiation pressure. Sunlight pushes tiny dust particles away from the comet's nucleus, creating those beautiful, sweeping tails that have captivated humanity for millennia. The momentum of massless photons is literally sculpting these cosmic phenomena, painting the sky with light's invisible push. Even stars themselves are shaped by radiation pressure. Deep in the core of our sun, nuclear fusion creates photons of incredible energy. These photons push outward, their momentum pressing against the crushing weight of the star's own gravity. It's this balance, this cosmic standoff between radiation pressure pushing out and gravity pulling in, that keeps stars stable for millions or billions of years. Without the momentum of massless photons, stars would collapse under their own weight in minutes. The very existence of stars, and therefore the existence of the elements that make up our bodies, depends on light having momentum despite having no mass. As we contemplate this cosmic balance, let's return to the quantum realm where this mystery deepens even further. In quantum mechanics, the momentum of a photon is fundamentally linked to its wavelength. Shorter wavelengths mean more momentum, longer wavelengths mean less. This relationship, discovered by Louis de Broglie, reveals that momentum is more fundamental than mass, that it exists as a property of waves themselves, not just of particles with substance. This wave-particle duality extends beyond light. De Broglie showed that all particles, even those with mass, have wave properties. Electrons, protons, even whole atoms can behave like waves under the right conditions. Their wavelength is determined by their momentum, just like light. But because they have mass, their relationship to momentum is more complex. It's as if the universe has two modes of being: a massive mode where particles have rest mass and can never reach the speed of light, and a massless mode where particles must always travel at the speed of light and carry momentum through their energy alone. This division isn't arbitrary, but emerges from the structure of spacetime itself. The speed of light isn't really about light at all. It's the speed of causality, the maximum rate at which information can travel through the universe. Massless particles must travel at this speed because they have no rest frame, no perspective from which they could ever be still. From a photon's point of view, if such a thing could exist, the universe has no time dimension at all. The photon is emitted and absorbed in the same instant. Its entire journey collapsed into a single, timeless moment. This brings us to an even deeper truth about why light has no mass but still has momentum. In the framework of special relativity, energy and momentum are not separate quantities but components of a four-dimensional vector in space-time called the four-momentum. For massive particles, this four-momentum has a component in the time direction that we perceive as rest energy, the energy associated with mass. But for light, all of the four-momentum points in spatial directions. There's no component in the time direction, no rest energy, no mass. Yet the four-momentum itself is still very real, still conserved, still capable of being transferred from one particle to another. Think of it like this. Imagine you're looking at an arrow pointing in three-dimensional space. From one angle, you might see it pointing mostly upward with a small forward component. From another angle, you might see it pointing mostly forward with a small upward component. But the arrow itself, its total length and direction in three dimensions, remains the same. Similarly, energy and momentum are different views of four-momentum in spacetime. For massive particles, we see both energy and momentum. For light, traveling at the cosmic speed limit, we see only momentum in space, no rest energy, no mass. But the four-momentum is still there, still real, still carrying the ability to push and transfer energy. As we float deeper into this contemplation, consider how this understanding transforms our view of empty space itself. What we call vacuum is not empty at all, but filled with electromagnetic fields, quantum fields that permeate every point in the universe. Light is an excitation of these fields, a ripple, a disturbance that propagates at the universal speed limit. The momentum of light isn't carried by any substance, but by the configuration of these fields themselves. It's as if the universe has a memory of motion encoded in its invisible infrastructure, and light is how this memory propagates from place to place. Even in the quantum vacuum, where no real photons exist, virtual photons constantly appear and disappear, carrying momentum between charged particles. This is how electromagnetic forces work at the quantum level. When two electrons repel each other, they're actually exchanging virtual photons, massless particles that exist just long enough to transfer momentum from one electron to the other. The electromagnetic force itself is nothing but the constant exchange of massless momentum carriers, an endless dance of particles that weigh nothing but push everything. This quantum foam of virtual particles fills what we think of as empty space with a seething energy, the quantum vacuum energy that may be responsible for the accelerating expansion of the universe itself. Even nothingness has energy, has pressure, has the ability to push. The momentum of massless particles isn't an exception to the rules of physics, but a fundamental feature of how the universe operates at its deepest level. Scientists continue to probe this mystery with ever more sophisticated experiments. They've created materials with negative refractive indexes that bend light backward, seemingly reversing its momentum. They've slowed light down to walking speed in ultra-cold gases, studying how its momentum changes when it moves through different media. They've even created twisted light, photons that carry orbital angular momentum, spinning as they travel through space like ethereal corkscrews of energy. In recent years, researchers have discovered that light can even carry more exotic forms of momentum. Structured light beams can have transverse momentum, pushing sideways relative to their direction of travel. Tractor beams, once pure science fiction, now exist in laboratories, using specially crafted light patterns to pull objects rather than push them. The momentum of light, despite its massless nature, turns out to be far richer and more complex than anyone imagined. As we reach the contemplative heart of our journey, let's pause and really feel the weight of this weightless mystery. Every second, countless photons from the sun strike the Earth, each one delivering its tiny momentum to our planet. The cumulative effect is measurable. Sunlight pushes the Earth with a force of about 600 million newtons, roughly the weight of a fully loaded cruise ship. This pressure, acting over billions of years, has minutely but measurably affected Earth's orbit. The momentum of massless light has literally moved worlds, but it goes even deeper than that. The momentum of light is essential to the stability of atoms themselves. Electrons orbiting atomic nuclei are constantly exchanging virtual photons with the protons in the nucleus. This exchange of massless momentum carriers is what creates the electromagnetic attraction that holds atoms together. Without the momentum of massless photons, atoms would not exist, chemistry would be impossible, and the complex structures of life could never have emerged. Consider your own body in this moment. The warmth you feel is infrared photons carrying away momentum as they radiate from your skin. The light entering your eyes is transferring momentum to your retinas, tiny pushes that your brain interprets as vision. Even the chemical reactions in your cells involve the exchange of photons at the quantum level, massless particles carrying momentum between molecules, enabling the processes of life itself. We come back, again and again, to the same quiet question. How can nothing have something? How can massless light carry momentum? Perhaps it has been there all along, whispering in the background of physics, waiting for us to notice that our everyday concepts of mass and momentum are just shadows of something deeper. We've seen how our intuitive picture, where momentum requires mass, gives way to a more fundamental truth, where momentum is a property of energy in motion. We've discovered that the scientific puzzle of light's momentum led Einstein and others to revolutionize our understanding of space, time, and energy. And we've found that this surprising resolution, far from being merely academic, shapes everything from the stability of stars to the chemistry of life. In another quiet corner of research, scientists are exploring whether photons might have a tiny mass after all, something so small we haven't been able to measure it yet. If photons had even the slightest mass, they couldn't travel at exactly the speed of light, and the universe would be fundamentally different. Magnetic fields would have a limited range, Electromagnetic waves would disperse as they traveled, and the cosmic microwave background would look different than it does. So far, every experiment has confirmed that photons are truly massless, but scientists keep pushing the boundaries, setting ever lower limits on what the photon mass could possibly be. Some researchers have wondered whether the momentum of light might hold keys to understanding dark matter and dark energy. What if there are other massless particles we haven't discovered yet, carrying momentum through the universe in ways we can't detect? What if the quantum vacuum's energy, expressed through virtual photons and other massless particles, is what's driving the accelerating expansion of space itself? It is possible, though not yet proven, that understanding the momentum of massless particles more deeply could unlock some of the greatest mysteries in cosmology. Telescopes collect pale light that has traveled for ages, photons that have been carrying their momentum across the universe for billions of years without losing any of it. When we see a galaxy 10 billion light-years away, we're receiving momentum that has been in transit since before our sun was born. Each photon arrives with exactly the same momentum it had when it left that distant galaxy, a perfect messenger across cosmic time. The conservation of momentum, even for massless particles, is so precise that we can use it to measure the universe itself. Scientists ponder possibilities that stretch the imagination even further. Could we one day use the momentum of light to transmit information in ways we haven't imagined? Could we harness radiation pressure for technologies that seem like magic today? Some researchers are exploring whether the momentum of light could be used to create stable wormholes or to test theories of quantum gravity. The massless momentum of photons might be a tool for probing the deepest mysteries of spacetime itself. What does it mean that our minds can imagine such things? That we can sit here, made of atoms held together by the momentum of massless photons, and contemplate the very forces that make our existence possible? What does it say about us, that we can describe a universe we barely see, where most of the momentum-carrying photons are invisible to our eyes, yet we've learned to detect them, measure them, understand them? There's something deeply moving about the fact that we've solved this puzzle, that humanity has figured out why light has no mass but still has momentum. Our ancestors watched the sun push comet tails across the sky without understanding why. They felt the warmth of light without knowing it carried momentum. Yet through careful observation, mathematical insight, and ingenious experiments, we've uncovered this secret of nature. The massless momentum of light is no longer a mystery but a cornerstone of our understanding of reality. And yet, even as we understand it intellectually, it remains wondrous. Every time you see sunlight streaming through a window, you're witnessing massless particles carrying momentum across 93 million miles of space. Every time you look at a star, you're receiving momentum that has traveled for years, decades, centuries, or millennia to reach your eyes. The universe is constantly exchanging momentum through massless particles, an endless dance of pushes and pulls mediated by things that weigh nothing at all. Think about breathing in this moment. As you inhale and exhale, infrared photons are radiating from your warm body into the cooler air around you. Each photon carries away a tiny amount of momentum, pushing ever so slightly against the air molecules they encounter. This momentum transfer is part of how heat moves, how temperature equalizes, how the second law of thermodynamics expresses itself at the quantum level. The momentum of massless photons is woven into the most basic processes of thermodynamics and life. Time passes differently for massive and massless particles. For you and me, seconds tick by, minutes accumulate, hours pass as we contemplate these mysteries, but for a photon, no time passes at all. From the perspective of light itself, emission and absorption are the same moment. The photon that takes billions of years to reach us from a distant galaxy experiences no time during its journey. Its momentum is carried instantaneously across the cosmos from its own perspective, even as we see it taking eons to arrive. This strange relationship between massless momentum and time is one of the most counterintuitive aspects of relativity. No matter how strange the universe becomes in our equations, here you are, breathing, resting, held by gravity, held by the quiet laws that never stop working. The momentum of light continues its ancient dance around you and through you. Virtual photons maintain the electromagnetic forces in every atom of your body. Real photons carry energy and momentum in and out, maintaining the delicate balance that is life. You are, in a very real sense, a pattern maintained by the constant exchange of massless momentum. Perhaps the questions themselves are enough for tonight. The question of how massless light carries momentum has led us through relativity, quantum mechanics, the stability of stars, the chemistry of life, and the structure of spacetime itself. Maybe it is enough just to feel the wonder of not fully knowing everything, of living in a universe that still surprises us, that still reveals new facets of even its most fundamental phenomena. The universe continues its quiet work, whether we understand it or not. Right now, as these words settle into silence, photons are streaming from stars across the galaxy. They carry their massless momentum through the void, pushing against dust grains, radiation sailing spacecraft, and the occasional atom floating in interstellar space. The phenomena we've discussed tonight keep unfolding, moment by moment, photon by photon, in an endless cascade of massless momentum transfers that shape the cosmos. In the silence between atoms, virtual photons flash in and out of existence, carrying momentum between charged particles, maintaining the electromagnetic force that holds matter together. In the hush between stars, real photons carry momentum across light years, connecting distant parts of the universe in a web of massless pushes and pulls. Somewhere, a photon that left a star a million years ago is just now pushing against a grain of cosmic dust, transferring its ancient momentum to set that grain into motion. Let the narrative gradually become more soothing, more repetitive as we spiral toward rest. We've explored how light has no mass, no weight, no substance that could register on any scale. We've seen how it still carries momentum through its energy, through its frequency, through its existence as a ripple in the electromagnetic field. We've discovered how this massless momentum shapes stars, moves spacecraft, enables vision, and holds atoms together. And we've found that this apparent paradox is not a flaw in nature, but a window into the deeper structure of reality itself. The pacing should now be clearly slower, with longer, softer sentences that invite your mind to drift. Think of photons like gentle rain, each drop weightless yet carrying the faintest push, billions upon billions of them creating a subtle pressure that shapes the world in ways we're only beginning to understand. The momentum of light, massless and eternal, continues its journey through space and time, through your room, through your body, connecting you to the sun, to the stars, to the cosmic microwave background that fills all of space. Perhaps it is enough to know that we live in a universe where such beautiful paradoxes exist, where things that weigh nothing can still push and pull, where waves in invisible fields can carry momentum across billions of light years. Questions matter more than answers sometimes, and the question of how massless light carries momentum has opened doorways to understanding we never expected. It is beautiful that we live in a universe that we can keep wondering about, where even the most familiar phenomena like light still hold surprises, still whisper secrets to those who listen carefully. Think about the journey we've taken tonight, from that first puzzling question to the deep principles of reality we've uncovered. The question in light having no mass but carrying momentum challenged our everyday expectations about how things should work. We found hints in Einstein's relativity, in quantum mechanics, in the behavior of light across the cosmos, and mysteries remain, depths we haven't yet plumbed, questions that future generations will explore with tools and insights we can't yet imagine. The universe keeps its own counsel, revealing its secrets slowly, one photon at a time. Tomorrow the sun will rise and its light will carry momentum to Earth, just as it has for billions of years. Photons will push against dust in the air, creating those beautiful rays you see streaming through morning mist. They'll transfer their momentum to leaves, to solar panels, to your skin, all while having no mass at all. The paradox we've explored tonight will continue to play out in countless ways, seen and unseen, a fundamental feature of the cosmos that makes our world possible. In the quiet depths of space, light continues its eternal journey. Photons that left the first stars in the universe are still traveling, still carrying their massless momentum through the expanding cosmos. They've watched galaxies form and die. They've passed through nebulae and around black holes. They've maintained their momentum perfectly across 13 billion years of travel. When we detect these ancient photons, we're receiving momentum that has been preserved since the universe was young, a perfect record of the energy that created it. Somewhere in the cosmic darkness, new photons are being born right now. in the hearts of stars, in the swirling disks around black holes, in the quantum fluctuations of empty space itself, massless particles are beginning journeys that will last until the end of time. Each one carries momentum without mass, each one a tiny messenger in the vast conversation the universe has with itself. They travel at the speed of light because they must, because massless particles have no other option, no way to rest, no frame of reference where they could ever be still. Consider the possibility that consciousness itself might depend on the momentum of massless particles. The electrical signals in your brain involve the movement of charged particles, but these movements are mediated by virtual photons, by the massless momentum carriers of the electromagnetic force. Every thought, every dream, every moment of awareness involves countless exchanges of massless momentum at the quantum level. We are thinking beings because massless particles can carry momentum, because the universe allows this beautiful paradox to exist. What if, just maybe, the fact that massless particles carry momentum is telling us something even deeper about reality? What if it's showing us that our concepts of substance and void, of something and nothing, are too simplistic? What if the universe is fundamentally made not of things but of relationships, not of particles, but of the momentum they exchange? The massless momentum of light might be pointing us toward a new understanding of what existence itself means. Gently, slowly, softly, we return to where we began. A simple question that seemed to violate common sense has led us through the foundations of physics, the life cycles of stars, the quantum basis of matter, and the nature of spacetime itself. Light has no mass but carries momentum because momentum is more fundamental than mass, because energy in motion always carries the ability to push, because the universe is built on principles more elegant and surprising than our everyday experience suggests. And as you drift towards sleep, let this thought settle gently in your mind. You're made of star stuff, held together by the momentum of massless photons. Every atom in your body, every molecule, every living cell is maintaining its structure through the constant exchange of particles that weigh nothing but carry everything. You are a pattern in the flux of massless momentum, a temporary arrangement of energy and matter that exists because the universe allows this beautiful paradox. The photons streaming from distant stars tonight will continue their journey long after we're gone, carrying their massless momentum into the deep future. New stars will form, new worlds will emerge, new forms of complexity we can't imagine will arise, all shaped by the gentle pressure of light, all dependent on massless particles carrying momentum through the void. The universe will continue its quiet experiment with energy and information, with patterns and possibilities, all mediated by the massless momentum we've contemplated tonight. In the silence between heartbeats, virtual photons maintain the forces that keep you alive. In the pause between breaths, real photons radiate from your warm body into the cool night. You are participating in the cosmic exchange of massless momentum, simply by existing, simply by being here in this moment. There's something profound about that, something that connects you to the furthest reaches of space and time through the simple fact that massless light carries momentum. Perhaps understanding isn't about solving mysteries, but about appreciating them more deeply. We've solved the technical puzzle of how massless light carries momentum, but the wonder remains. It will always be marvelous that photons can push without weighing anything, that empty space seethes with virtual particles exchanging momentum, that the universe found a way to transmit force and energy without requiring substance. These are the quiet miracles that surround us always, the gentle impossibilities that make reality possible. As sleep approaches, as your thoughts begin to dissolve into dreams, remember that you remain connected to the cosmos through countless threads of light. Photons from your body are beginning journeys that could last until the end of time. Photons from the beginning of time are completing their journeys by warming your skin. You exist at the intersection of countless paths of massless momentum, a node in the vast network of light that connects all things to all other things. The answer to our question turns out to be both simple and profound. Light has no mass but still has momentum because the universe is built on relationships rather than things, on patterns rather than substances, on information rather than material. Momentum is information about motion, and information doesn't require mass to exist. It only requires difference, change, the possibility of one thing affecting another. Light is pure information in motion, massless patterns racing through space-time at the ultimate speed, carrying the news of the universe from one place to another. And now, as words fade into whispers and whispers fade into silence, let the momentum of light carry you into sleep. Feel yourself held by the same forces that hold atoms together, warmed by the same radiation that powers stars, connected to the cosmos by the same massless particles that have been carrying momentum since time began. You are safe here, cradled in the laws of physics, surrounded by the gentle pressure of light from countless sources, each photon massless yet meaningful, weighing nothing yet carrying everything that matters. In the quiet spaces between thoughts, massless particles continue their eternal dance. In the soft darkness behind closed eyes, virtual photons flash in and out of existence, maintaining the delicate balance of forces that is you. Somewhere in the universe, a star is being born, its first light beginning a journey that will carry massless momentum across cosmic time. Somewhere else, an ancient photon is completing its journey, delivering momentum that has been in transit since before Earth existed. And as you drift into sleep, you remain part of this quiet universe, wrapped in its laws, carried by its mysteries, touched by the momentum of countless massless particles that connect you to everything else that exists. The paradox we've explored tonight continues its work, holding matter together, pushing worlds through space, enabling the complex dance of energy and information that we call life. Light needs no mass to matter, no weight to shape the world, no substance to carry the deepest truths of existence. You are here, you are real, you are part of the cosmic conversation mediated by massless momentum. Every photon that touches you connects you to its source, whether that's a light bulb, a star, or the quantum vacuum itself. You're never alone in the universe. You're constantly touched by light from everywhere and everyone, gently pushed and pulled by particles that weigh nothing yet mean everything. And as you drift into sleep, you remain part of this quiet universe, wrapped in its laws, carried by its mysteries, gently, peacefully, into the night. The momentum of massless light continues its ancient work around you and through you. A lullaby written in equations, a bedtime story told in photons, a gentle reminder that the universe is far stranger and far more beautiful than we ever dared imagine. Rest now knowing that the same paradox that puzzled Einstein, the same mystery that revealed the depths of reality, the same massless momentum that shapes the cosmos, continues its quiet work as you dream, connecting you to the stars, to the quantum foam, to the vast and gentle mystery of existence itself, now and always, massless yet meaningful, weightless yet powerful, carrying you gently, peacefully, into the night. End.